Number 28. This is going to be a little more complicated than 27, so getting the left and the right side Riemann sums. That's what they're called. Left Riemann sum, the right Riemann sum. So if you haven't taken a look at 27 yet, you might want to do that. We'll use the same process. I'll just kind of give a screenshot here. We're making rectangles, so we're going to graph it. We'll make left rectangles, right rectangles, add them together. That's all it is. It's just that there's now going to be 8 rectangles instead of just 4. So in a way, it makes it maybe easier to understand. So let's go ahead and go. So we're going to integrate this from 2 to 6. This is our function that we're integrating. We're finding the area under this curve, and we're going to use 8 different rectangles, or we're dividing it into 8 rectangles. So what we do is to figure out how they start and everything, we take 6 minus 2, because that's how much space we're going over. We're going from 2 to 6, so we take 6 minus 2, that gives us the amount of area. 6 minus 2 is 4. We're going to divide that into 8 rectangles, so we divide it by 8, and that gives us that each rectangle will have a width of 1/2. 4 divided, 1/2. And then we'll go from there. So we're going to first get the graph. We're going to draw the rectangles, and then we'll go from there. Okay, so we're going to come here, and we're actually, we have to graph it. So we go, let's clear this out. 1 over x, 1 divided by x, plus 1. That's what we're integrating. Now, the 1 is not in the denominator. If you want to, if you're not quite sure, put a parentheses. Watch this. If you go second, there's an INS for insert. You can insert things here, and it moves everything so you don't have to retype. Okay? So that's what we want to graph. We want to go from limits of x equals 2 to x equals 6. So let's go set our window at that. Let's go from x equals 2 until x equals 6. That'll be a nice tight fit. And again, we kind of eyeball how high do we need to go? Do we need to go to 80? Well, if I put 6 here, that's 1/6 plus 1. It's a little bit more than 1. If I put 2 here, that's 1/2 plus 1. So maybe all I really need to go is to 2, and I'll see everything. If I go to 80, I won't see much, right? So I'm going to go to 2. I could go as far like 1.5. Let's actually 1.75. Because I know 1 plus 1/2 is 1.5, but that's actually going to be the highest I need to go. Okay, if you're not sure, go ahead. You graph it, and then if it's not what you think, see, I can see it all. So we're good. We're good here. This is 2, 3, 4, 5, and 6. So we want to remember that. I'm going to take a screenshot of this and then make 2 copies of it, one for the left side and one for the right side Riemann sums. Okay, I'm going to paste that here. Let me make this a little friendlier. Oh, I lost my, it didn't really lose it, just now it's underneath. Let me do this. Let's go with this one. There we go. That's better. Still tight, but it's underneath all the other stuff. And I'll make this a little bit smaller so that when I paste, well, I want that up there. So again, I'll make it so it can go anywhere I want it to go. So it's tight, and then I'm gonna, where's the other one? Let me just paste it. And we'll make this one also tight and move it down here. So we'll do one for the left side, one for the right side. We'll label these. This is going to be the left side. This is going to be the right. Okay. So for and I'm gonna, since we're gonna each space is going to be a half. Remember, this is 1, so I'm going to kind of cut each of these in half. And then remember, I'm going to label them. This is x equals 2, so this is 2.5. This is 3. This is 3.5. This is 4. This is 4.5. This is, what comes after, that's 5. 5.5. And then 6. So when we do left, and again, there's a lot we're doing. We go from the left side, and we make our first rectangle all the way to the top. We go over till the next division, and notice this time we're slightly overestimating with the left, which means when we do the right, we'll slightly underestimate. The next one is 2.5. We come to where it hits the graph, and we make our rectangle to the next one. And again, we're going to get all of these, and then we do at 3. I'm going to go f of 3 here, come over to the next one. Just a slight, notice as it gets closer or down to a sort of a horizontal line, we get a better and better estimate. So this one's actually fairly good, better than what we did with 27, probably not as much space. Down 4.5, we start at the function and go over to 5, and notice it looks like it's going to be a very good estimate. We go from here to there, and then we go from here to 6. You notice we have 1, 2, 3, 4, 5, 6, 7, 8. The base of each of these is 1/2, so I'm going to put it outside, and then what I've got is the y values is the function values. So we get f of 2 plus f of 2.5 plus f of 3 plus f of 3.5, and so forth and so on. Okay, all the way. Now the last one we do though is just f of 5.5. Notice we'd have 8 of these. You could list them all out. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. We don't do f of 6 on this one. That goes with the right, but the right doesn't have f of 2. So you'll see that. So we go all the way to f of 5.5. And again, the last video I showed you using the graph where you could actually find the value on the graph, and that helps in the learning process. So again, I encourage you to do that. We're going, with this one, since there's so many of them, we're going to go directly to, why did you do that to me? We're going to go directly, these computers just start doing whatever they want to do. We're going to go directly to the table. Well, sort of. We're going to set up the table set. We want it to start at, oh, cool, 2 to 6. I wonder, oh, I already set up the window. No, I want table set, not window. So I go second, table set. I want it to start at 2. That's what I was surprised. How did it know what I wanted? And we want it not to change by 1s because we need these 0.5s. So we want it to change by 0.5, by a half. So that when we go to our table, second table, notice it's above the graph key, we've got all the things we need, 2, 2.5, 3. So we're going to start writing these down. What we get is, these are the y values, right, the function values. Let me just see. Oh, good. They're letting us go to decimal places, so we don't have to worry about fractions, because I certainly don't want to deal with all of these fractions. 3 decimal places though, so with addition we want to have at least the 3 decimal places. So f of 2 is 1.5, f of 2.5, notice that's right here. I can't really write on this calculator, but it's alright, it's 1.4. And then f of 3 is 1.33. And again, we want 3 decimal places, so we'll put 3 decimal places, 3.5, and that's the dot dot dot, 1.286. 1.286. Let's round that part up. Actually, I probably should go to 4 and then round at the end, right? Actually, just to be sure, because otherwise I might be off by a thousandth, and we don't want to do that. So when you're going to round to 3, round to 3 decimal places in your calculations, you actually need 4 and then round at the end. This is just a chance, so we'll put one more there, and then this one. So again, hopefully you see the process. Let's see, where are we? This is 2, 2.5, 3, 3.5, 2857, 2857. And since it's only showing 4 decimal places, it's probably rounded that last one, which is okay, but we don't want to round too early. Okay, 4 is 1.25. So there, I've got to come around here. 4.5 is 1.2222. And again, 4 decimal places, then we round at the end. F of 5 is 1.2. And then I have to go all the way to 5.5. So I have to arrow down. There's my 5.5, 1.1818. Okay, count them, there should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Now I just need to add them all together. Again, tedious, but necessary. I know there's people who take videos and they'll fast forward through stuff like this, but sometimes, it's this kind of stuff, how to actually enter in, maybe not just addition, but so we got our 10 point, so it's going to be 1/2 times 10.373, so it's rounded it for us to 3 decimal places, and then we divide that by 2, multiply by 1/2, divide by 2. So then that's going to be 5.18. And again, now, since this is really the last step, we will go ahead and round it to 3 decimal places, so that 6 becomes a 7. So that's why we want to be careful when they're asking for the decimal places. Oops. So what is it? 5.187. And again, you see what we're doing. As a check, I'm going to go ahead and do since we've got the graph here, back to the graph, let's use the calculators feature, second calc number 7, to actually calculate the exact, not Riemann sum, but exact integral going from 2 to 6. You can see, fill it all in, and it tells us 5.099. Right? If we round that 5.099. So the actual 5.09. Why it does that to me? So, we're close. We're a little overestimate, as we were saying. And we'll see probably the right side will be a little bit of a underestimate. And then when we average it, we'll probably come very close. I bet you, let's set a pool. I bet you $1 million. It'll be about 5.1. No, we won't. Don't need to bet money. But I bet you it'll be about 5.1 that we end up with our average. So that's the left-hand side. Now notice there's 2 questions here. We're probably only going to be 1 on the test. I would hope it's closer to the 4 interval one, but this really hopefully solidifies what we're doing with Riemann sums. But I guarantee you can expect a Riemann sum on the test. It's, well, again, I won't bet any money on it, but it's very highly likely. So let's draw this one. I'll go with the red. And again, this one I'll do a little bit better. I'll start at the right side, because that's what we do. We start from the right and we work to the left, and that's what we get. Again, our intervals are by 1/2. So I have the same thing. I'll label them to 2.5, 3, 3.5, 4, 4.5, 5, 5.5, and 6. So starting at the starting at the right side, we make our first rectangle We go until we hit the graph, and then we go over to the next one. So maybe just a slight underestimate there. We could start seeing that. And then 5.5, we make another one. We're up here just a little bit higher, and then we go over to 5. It's almost, that one's a very good estimate. And then we go to 5, just a little bit higher. We go over to 4.5. And again, we don't technically, I mean, we're not doing anything with this. You don't have to turn these in, but I just want you to see what a Riemann sum is doing. And just think of these people 300 years ago, no technology like we have. This is what they could do. They still had paper and pencil, or maybe papyrus and pencil, or maybe pencil and a tablet, a clay tablets. You could do this with a tape, or you could even do this in the dust. But you can calculate this, and but you know what? I think our past ancestors, there were times, we don't know everything that happened. There were times when their technology was probably far surpassing ours. That's what they called magic. We call it technology today because we know what's going on. We share it. Then they called it magic because they didn't let everyone else know they used it. Maybe some used it for power over others. Maybe they needed it. Maybe some things shouldn't be shared when we see when people use it for the wrong reason. So again, I'm just drawing rectangles here, so that's why I just talk about things. And you see, so we're getting these right triangles. And actually, my students at the community college used to say, they compared me to that guy on the public broadcasting, Bob or something, but a guy, real fuzzy hair, hide artist, and he would just talk as he did his pictures. And I said, oh, that's kind of cool. I like that guy. He passed away not too long ago, but I wish I could draw like him. Obviously, I don't get, fortunately, I don't get paid for my art because it's not so good. Anyway, we started here. We're going back. We've got 1, 2, 3, 4, 5, 6, 7, 8. And what we're going to do is we're going to calculate the area of the rectangles. Each rectangle has a base of 1/2, so we can kind of factor that out. And then we get the heights. And again, we got the heights from over here as well. We just get that off the table. And as we saw, we start with not F, we don't go here. The last one was 2.5. And again, you could start from the right if you want 6, 5.5. Order, you could do it in any order. We'll do it this way. But just to emphasize, we don't start with 2 because this is the right side. We started with the right side. And we've got our 8 intervals by that time. Actually, I've never done that. A lot of times when you do start it, so we're starting at the right-hand side, let's just start at the right-hand side. Maybe that's why I never really understood it. You always come back here and say, so we're starting at the right-hand side, and we count all these intervals until we fill up the 8 that we need, and that's, sorry, I shouldn't talk too much. 5.5 plus 5, f of 5. And again, we keep going all the way down to, so we got 1, 2, 3, 4, 5, 6, 7, 8, down to f of 2.5. Okay, so we're going to look all those up, add them up, multiply by 2, and go to the table, and our table should be already set up for us, and we just need to arrow down a little bit more to get our 6, and we'll start with that. So move this over 1/2. We get 1.1667, going out 4 decimal places. F of 5, 1 point, and again, these ones we've already had, but they're now in the right hand. But if you just see the numbers and you don't see the graph and what we're doing, it doesn't make as much sense. Maybe it doesn't make any sense. 3.5 is 1.2857. So again, we're coming from the right. 1.3333 4 times, and then the last one we need is the 2.5. So we go up to that. 2.5 is 1.4. Okay, and we count 1, 2, 3, 4, 5, 6, 7, 8. That's what we need. We add these together, then divide by 2, and that's our answer. So again, come back, clear out that stuff, and 1.1667 plus 1.1, careful there. See, this is the kind of things you got to watch. This is where the errors creep in, and then we think we did everything right because we've got the process down, but we made an entry error, manual error. Those things are just as important as anything else. Ask any athlete. You can know how to do a certain thing cognitively, but if you don't execute it correctly, say you're jumping over a high bar or something, you drag your foot a little bit, boom, the bar goes down. Math, the equivalent is not hitting that decimal key. That's it's kind of like a small thing, but it ends up being a big thing. Just like everything in life, that's what this is about. And even sports. But all my coaches told me that. This is about learning how to live. So we got similar. So we got our 1/2 times pretty close. It's a little bit smaller than the last one. It was 10 point something else. 397. We leave all the decimal places this time. We're going to divide that by 2, and that gives us 5.0198. We're going to round it to 3 decimal places, so that 8 actually is going to get rounded up to a 9. Let's see some. Oops. What did that do? I undid something, but hopefully it's nothing too important. Let's erase. Just round that up to a 9. So then we go 5.01. Oh, wait. 3 decimal places. 1, 2, 3. Actually, this 9 needs to get rounded up, right? I was miscounting my decimal places. And again, dragging my foot again, knocking that bar down. So we want the 9 to round up. So that's going to be a 0, and then the 1 becomes a 2. So this is the one time when you round, you actually end up rounding up 2 places, because whenever you have a 9 that gets rounded up, it carries over to the next one. And see, I think we're going to be pretty close if we average this, maybe a little bit bigger than 5.1, and then the average, take the 2, add them together, and then divide the whole thing by 2, because there's 2 things there. So I'm going to take, let's just take the rounded answer, 5.187 plus 5.020. Hit enter. If you just divide by 2 there, you got to be careful. Order of operations, you're only actually dividing the 5 by 2, and then you're adding. So be careful with this step, because again, that's a lot of times where I see you'll get everything else right, and then it'll be a calculator error, because or you got to stick with the order of operations. So we do the top first and then the bottom. 5.1. I was a little off. It's a little bit, but it's pretty close to 5.1. And so, if you round this up, there's our 5.100, 5.10. So, we're right on up into the hundredths place. So, very accurate way of doing it. And again, this is hundreds of years old. This worked back then without any of these graphing calculators. So our engineers in the past, they built pyramids, they built all sorts of stuff, and some of it better than what we build today, because it's still around, and some of our stuff don't last more than 10 or 20 years. But anyway, the mathematics, the power of the human mind is beyond understanding. That's the truth. So keep developing your mental abilities and make great things happen. All right, thanks.